Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at an API to return weather data from a website. An application programming interface, or API, is code that enables two software programs to communicate. An API defines how a developer should request services from an operating system or other application. Today we are going to use a specific website's API to return data on the weather. The application we're going to create today uses the API libraries from Jose Roca. These, as you will see, can be downloaded from this URL. The website we're going to be using today for the weather data is the Open Meteo website. So before we get into the code, we're going to have a look at that website. This website allows you access to a great deal of weather forecasting data, and the API is quite impressive. This documentation screen can be used to build up the URL we're going to be using within our application. So first we will set the location that we are interested in. So having selected your location, it has populated the latitude and longitude boxes. We can next set the forecast length time. At the moment I'll set it for 1 day. Next we will set the hourly weather variables. This will return information on the estimated temperature at 2 meters height on each hour of the current day. If we skip past all the other settings, these settings allow you to set whether you want the temperature in Celsius or in Fahrenheit, whether you want the wind speed in kilometers per hour or in meters per second or miles per hour. And precipitation, once we select that, will be done either in millimeters or in inches. As you'll see from the license usage, you can use this for non-commercial use, as long as you make less than 10,000 daily API calls. So if we scroll down further, we will find the API response. This is the information that the API is going to return. If we just hit the reload chart, it will report on the temperature on each hour of the current day. While you can download this as a CSV file or as an Excel spreadsheet, what we are principally interested in is this line here. This is the URL and the API details we need to plug into our program to return this inside the application. So first of all, we will copy this URL and we'll pop back to the code now. So this is a URL we're going to be using. I'm going to split the URL up into two parts, the first being the site and the second being the parameters for the API. In order to get all this to work, we need to add two additional libraries to our PowerBasic application. Now that these are added, there are two constants I'm going to add to our application. We're not going to be using these constants in today's application. This is because this particular web API does not require authentication. However, if you are actually adapting this program to use other web APIs, they may indeed require authentication, so you'll need to be using one of these set credential constants. We'll cover that later in the code when we get to that point. So now we're going to set up the code to allow us to access this web API. We're going to set up 4 local variables. The first variable is the one for the URL for the website. The second is for the string of characters, which is our call parameters to the API. There's always a possibility that some error may be generated. Therefore, we're creating an error variable to hold any error message. And the data coming back out of the API, we're going to put into a result variable. So how do we actually call this API? Well, our first task is to set up another variable. In this case, this is our HTTP variable. And we're setting that up as an iWinHTTP request. And we're going to be using a COM object here. As you will see from new COM, this is an object reference to an object variable. In this case, we're using this format. Object variable equals new COM and then a prog ID. So the prog ID we're using in this case is this one here, a win HTTP request 5.1. If we are unable to instantiate this particular object, then the isNothing will return true. If that's the case, we can exit immediately, because we have been unable to instantiate this particular object. So to give it some feedback, we'll put a message out to our log to say that we're about to connect to the API. And we will set our URL variable to be the site we're going to be querying. And we will set our API variable to be the parameters. So we're looking for a forecast, we're telling it the latitude and longitude, and we're setting it for hourly temperature for 1 forecast day ahead. So now that we have our parameters set up, how do we make the call to the website API? Well, we're going to create a new function called getAPIOutput, and we're going to pass these variables over to it. We will create this new function in a moment. But as you can see, it's taking 5 parameters. And if this returns true, then we will have information in the result variable. And what we want to do is we want to output this result to a file. And to do that, we're going to use one of the functions in our file handling library, append to file. This will either append to an existing file, or if that file does not exist, it will create a new one. And we're going to call our output output_start.txt. And should our function fail, then the error variable will contain details of the error. So we will put that out to our log as well. Since the data within this error variable is a wide or Unicode string, we'll use the acode $command to turn it into a normal string which we can put out to our log. So now we need to create this new function, the getAPIOutput function. This is going to be a generic function. This can be used for many different websites. And here is the skeleton of our function, taking its 5 parameters. The object for the HTTP call, the URL, the API string, the error string which will be output, and the result which is also output as a string. So we have created a number of local variables within this function. And now we can attempt to attach to the web API and pull the information back. We're going to do this within a try-catch block. Our first task is to do an open on our object to get the information from the URL and the API string. Although this particular web API does not require the setting or use of credentials, this is the code you would need to use should there be credentials. Either credentials for the server or credentials for the proxy, depending on the website API you are connecting to. In this case, we don't require these, so I've commented them out. Next, we're going to use the send command to send our data off to the website. Having sent the data off to the website, we now need to wait for a response from that website. So we're calling the wait for response for the object. Once we get a response, we need to actually turn this into something we can actually use. Here we're populating the vStream variable, taking the response stream from our object. And as this is a variant, we're testing the variant type. If it's equal to VT unknown, then we can make use of it. Having got that far, we now need to pick up basically the buffer. This is the information coming back from the website. We're then using CB size to return the number of characters in our response. That number is used via the $$ command to populate the str buffer with that number of spaces. So our str buffer will now be big enough to hold the information that has come back. And we can then use the read command to populate the buffer with that data for that length, using string pointer to point at the location in memory in which our buffer actually sits. We're then doing a test to ensure that our buffer contains just the information we need with no blanks on the end, using the left $ command. And having got that far, we can then make the PI stream equal to nothing. This frees up the memory used by that. So we have data within the buffer. If the buffer is greater than 0, then we have some information returned. It's always possible we got no information at all, So we're going to test the length of that buffer to ensure it's greater than 0. If the length of the buffer is greater than 0, we can populate the result variable. So as we're doing this in a try-catch block, we need to handle any errors that come up. In this case, for populating error, we're going to be using a new function, the getOLE_error_info, passing it the object result. And in that case, we will return false. So here is this new function, which is going to be calling another API call, OLE_getError_info, to return the string which contains our data for the error. So we can now compile the application quite successfully. So that should be all the code we need to actually call this weather API and return some data and create it within a text file. So let's try running that code now and see what we get. Well, it tells us the data has returned. So let's have a look in our folder to see what's in the output.txt file. And there is our output.txt. This is one exceedingly long line of data. However, it's not very readable from a user point of view. So we'll need to parse it to make it a little more readable for human eyes. So we're going to call another new function called parseJSON. This will parse this JSON string into something that is a little more human readable. And we will add that to our output file. So I've added this parseJSON function to the end of our application. I'll leave you at your leisure to look through how this function actually performs. But it's basically using the string builder class within PowerBasic to build up a string from individual characters. And it's going through all the characters within our JSON string and making that a little more human readable by adding character turn line feeds at the end of significant points. So if we try running our application again, it runs, gives us the data, and let's have a look now at the output. There is our output file. If we open that up, we will see we have the original string in one line, and our new parsed string is much easier to read. It's telling us, first of all, the input we gave it, the latitude and longitude, the time zone, the elevation, the hourly units, and the temperature, which is the information that we're interested in. And it's going to return the temperature in Celsius. Below this is our hourly data. This is the data we're specifically looking for. It gives us two lines of data, one being the time, the date, and the time of day in 24-hour clock. So we can see that is midnight, this one is 1 o'clock in the morning, and so on. And below this is our temperature. So the 10.9 is the temperature in Celsius at midnight on the 23rd of December 2023. It remained the same at 1 in the morning, and at 2 in the morning it dropped down to 10.7. So you can see we have successfully returned data from the web API. Now that we've actually parsed that information into a more human readable format, it's also easier to read within your code. The string we have is a number of lines, delimited by a character turn line feed. This can be stepped through in your code in a simple for next loop to look for the two key pieces of information you're looking for. So what if we're after more than just temperature? What if we want rainfall as well? Well, let's go back to the website and see what we can do to get that. If we scroll back up, we'll see we have currently ticked for temperature. If we look for rain, and then we scroll back down again, it recognizes we've changed the parameters and need to reload the chart. Now it's showing you the rain in the chart. So we can pick up the API and we can populate that in our code. So there is our amended API string. We're picking up temperature and rainfall. So let's try running that code now. And if we have a look at the output file, we will see at the bottom of the data we have another row of data. We have rain, and it's telling us the amount of rain, in this case in millimeters, for each hour of the day. So the data coming back from this weather API is easily interpreted. And should you need to amend the API, you merely have to go onto the website and tick the types of information you are interested in. You can then amend your application to pick up the key pieces of information you're interested in. So in summary, what we've done today is we've created a generic application that can be used to query a website via its API and pull information back. This particular website is very useful in that it generates the API call for you, and therefore makes it very easy to select the types of information you're specifically interested in. What we will do in the next video is we will look to actually chart this information within your application. However, that's it for today. Thank you for watching.